A very good morning. Let's begin with the topic that is today's topic, electronic configuration. But before starting this, I just want to revise you the first 3 to 4 minutes what we have actually studied in our previous class. Okay, basically we have studied about electronic configuration since our last 2 lectures, but the point is we have studied that only on the basis of laws and rules like Pauli exclusion principle, Hunt's rule, Afbu principle, है ना? But we are going to discuss that, we are going to make that in practical application, and that is our next topic, electronic configuration. Okay, class, as I have already told you, electronic configuration is the most important topic of chapter number 2. It is the last topic and it is the most important topic of this chapter. I have told you that this is not only important for your exam point of view, but also for your whole chemistry. Till now, you would keep studying the chemistry, you would get the topic electronic configuration. Okay, so keep that in your mind that electronic configuration is super easy and super important topic. Okay, so we will start with the electronic configuration. So the first point is, what is the electronic configuration? How can we define the term? Okay, before going to the topic, let me define. Electronic configuration is nothing. It's just the filling up of electrons in atomic orbitals. Yes, electronic configuration is just telling us that we are filling up our electrons in atomic orbitals. Okay, this is something in which we are going to fill our electrons in the atomic orbital. And the point is, how can we fill up our electrons in atomic orbital? That is totally based on the laws and the rules we have studied. Energy, the quantum number n, the quantum number L, that have given us the idea about 1s, 2s, 3s, 2p, 3p. And the rules that we have studied in our previous class, just the yesterday, that were Hunt's rule, Pauli's rule, Afbu principle. These rules have told us how can we fill up our electrons in atomic orbital. Okay, so should we start? Okay, let's begin. So before starting electronic configuration, the first point is by Afbu principle that we should first of all make our electrons arranged in the form of energy. I have told you that Afbu principle have told us that whenever we are filling up our electrons, the point is we should fill up our electrons in the increasing order of energies. Okay, so we have studied that. But the point is, how can we apply the topic that we can fill up our electrons in the order of increasing energy? Energy. The atomic orbitals must be kept in the increasing order. So let's begin. For understanding this, I have made a brief idea, a brief small short diagram. This is nothing. This is all the atomic orbitals. But the point is, it's like a short trick so that we can remember how can we make our atomic orbitals in increasing order. Okay, so let's begin. We have just arranged the 1s, 2s, 3s, 4s and 5s in vertical form. सिर्फ और सिर्फ vertical form में उठा के रख दिया है मैंने. Same as it is the 2p, 3p, 4p and 5p. Same as it is 3d, 4d and 5d. Now a question, a doubt must come in your mind. There is 1s, but there is not 1p. है ना? Same as it is, there is 2p, but there is not 3d. Sorry, 2d. So the question is, why is it so happening? I have taken 1s, but not 1p. Same as it is, I have taken as 2p, but not 1d and 2d. है ना? So the point here is the basic reason behind this concept is the principal quantum number n. What principal quantum number n has told us? N has told us that there must be n minus 1. जो L है, that must be equal to n minus 1. Only then we can say that this atomic orbital exists. है ना? Whenever we have studied our quantum numbers, remember that topic. उस टॉपिक में हमने ये बात particularly study की थी that अगर हम putting our L in the form of n minus 1, only then that atomic orbital can be exist. Only that atomic orbital exists in our real life. Okay, so 1s must exist, but 1p cannot exist. Why is it so? Because L equals to 0, 1, 2 and SPDF. So if I'm talking about 1p, times N equals to 1, and for P, L equals to 1. But this is not possible because I have told you L must be less than N always. Okay, so that's why 1p do not exist. Same as it is if I'm talking about 2d, that is also not exist because d has the atomic orbital number L equals to 2, and if N equals to 2, that's not possible, है ना? So we are rejecting these topics. या फिर हम इसको सिर्फ अपने याद रखने के लिए ये बोल सकते हैं कि हमने 1 जो है वो S को प्रोवाइड करा दिया है. So if I'm starting with P, I cannot start with 1. मैं 2P से start करूंगी. Now P has already taken the number 2. So we will start with D with 3 number. Okay. Same as it is, we have S, P, D and F. So 3D, then we can say 4F, 5F and so on. है ना जी? But the point is they are beyond our syllabus. That's quite high topic. You will just study about the F orbitals in class 12th, chapter number, I think 8th. Okay, just a single chapter is based on F block elements. Okay, so we will not going to study this topic right now. We will just focus which is important for us right now and which is for totally based on our exam point of view. Okay, so let's start. Now, as I have arranged all my orbitals like 1s, 2s, and same as it is 2p, 3p, 4p, 5p in the form of vertically, in the form of energy. Okay, so now what I am doing, I'm just starting it in the form of this, like 1s is at the highest, then I'm going to 2s, then I'm going to 2p and 3s. Why is it so? Because मेरा जो 2p और 3s है वो एक same level पे आ गए हैं. I have put them in vertical form, then 2p with 2s, and I have started that in the first I have taken 1s, then 2s, then 2p and 3s in the same form. Same as it is, then there is 3p and 4s. Same as it is 3d, 4p, 5s and so on. We would keep going. Okay, but the point is हमें कितना याद रखना है अभी के लिए हमारे पास क्या इंपॉर्टेंट चीज है that is only up to 1s 2s 2p 3s 3p 4s 3d 4p 5s. Maximum we would come up to 3d and 4p right now. Okay, but you must remember how can we arrange them in order of increasing energy. This is not something based on rule. The rule is saying that 1s 2s are arranged in the order increasing n as well as n plus l. I have told you ना कि अगर हमारा n plus l value कम है, then it have the lowest energy as compared to other one. Suppose I'm talking about let's say 4s. The 4s has n plus l equals to 4 plus 0 equals to 4 only. And if I'm talking about 3d, it is 3 plus 2 equals to 5. So 4s energy then 3d. That's why 3p, 4s, then I'm jumping to 3d. है ना? But it is just a short trick to keep that in your mind. Okay. Now let's. I have given you the idea that how can we fill up our electrons in increasing order of atomic orbital. Now we are going to begin with the topic that how can we fill up our electronic configuration? How can we represent our electronic configuration? Okay, so let's start. Now the point is electronic configuration is just filling up of our electrons in increasing order of atomic orbitals. It has two representation in which our electronic configuration can be filled. The first one is this one, like 1s, 2s, 2p, 3s, 3p, 4s, and so on. we will keep filling the electrons in this order. और ये कैसे होगा? That would be based on atomic number. For example, hydrogen has atomic number only 1, so that there should be only one s. Okay, so that is our first topic, that is our first representation. Now the second representation is on the basis of atomic orbitals. We have arranged them atomic orbitals in the form of increasing order, same as it is. I have told you that we can make them in the form of block diagram. And what is the block diagram? Suppose I'm talking about 1s. The s orbital can be represented by one orbital only. This we have described in our previous class, है ना? Same as it is 2s, because है तो ये भी s orbital. Either it is 2 or 3, doesn't matter. There should be only 2s, only one atomic orbital. Same as it is if I'm going to p, the p must have 1, 2, 3. 3 representation. Why? Because p has px, py, pz, -1, 0, +1. Same as it is, I'm going to d. D must have 5 representation. 1, 2, 3, 4, 5. Because d has 5 representation. -2, -1, 0, +1, +2. Okay, so that's it. Now we will just going to do with the representation with the help of example. Now that I'm going to teach you how can we fill up our electron on the basis of atomic number. And electronic configuration, बच्चे ये damn sure 110% आपके final exam में आएगी. You are given a particular atomic number, a particular atom, and you have to make up the electronic configuration. Okay, so let's start. Let's take a normal simple example with hydrogen. I'm going to run through the whole topic. Let's begin with hydrogen. See, first I'm teaching you with the first representation, that is with the help of this. Now, if I'm talking about hydrogen, hydrogen has atomic number only equal to 1. That means there is one electron only. So first of all, we have one s and one electron. Khatam ho gaya. One electron is over there, and the one electron must be filled up in s orbital only. So there should be one. Now I'm going to jump with hydrogen, then helium. वही होता है ना second, hydrogen, helium, lithium, beryllium. So helium has Z equals to 2. That means 1s2. है ना जी? Same as it is, if I'm going to lithium, the lithium has Z equals to 3. Now the point here is, the twist here is, according to Pauli's exclusion principle, he has told us that every atomic orbital must have only 2 electrons. और वो दोनों इलेक्ट्रॉन्स जो हैं वो अपोजिट स्पिन में होने चाहिए. बोली थी ना ये बात हमें. तो we cannot do 1s3. That is not possible. What would we do? 1s2, because it is maximum field. Then we would jump to the second, 2s1. Okay. Same as it is hydrogen, helium, lithium, beryllium. Z equals to 4. 1s2, 2s2. Then I'm going to boron, Z equals to 5. 1s2, 2s2. Now 2s is also completely filled. So 1s हो गया, 2s हो गया. We would jump to 2p. So 2p1. Okay, same as it is, we will keep going. But the point here is कि हमारा जो p orbital है उसके पास efficiency है 6 इलेक्ट्रॉन्स को फिल करने की. क्यों? क्योंकि उसके पास 3 अलग अलग एटॉमिक ऑर्बिटल्स हैं और हर एक एटॉमिक ऑर्बिटल के अंदर कितने इलेक्ट्रॉन आ सकते हैं? मैक्सिमम 2 इलेक्ट्रॉन्स. सो p has tendency to keep the 6 electrons. I have told you that this represents the plus half spin, this represents the minus half spin, and Pauli's rule also told us that or two electrons must have the opposite spin. Okay, so 2p1 we can keep stretch it up to 2p6. So let me take a simple example of 2p6. That is our neon. That is our neon. But say this is so simple that 1, 2, 3, 4, 5, 6, 7, 8, 9 we will keep going and we will keep filling the 2p1, 2p2, 2p3 and 2p4. है ना? बहुत simple है. Now same as it is if I'm talking about neon that has Z equals to 10, that is 1s2, 2s2, 2p6. Because अभी मैंने आपको बताया कि हमारा जो p atomic orbital है that has 3 different atomic orbitals. और हर एक atomic orbital has the tendency to maintain 2 electrons in that. Okay, so there must be 2p6. This is completely filled. Now no more extra electron can come to 2p. Okay, so that's it. That's all about it. Now we are going to move with our higher atomic number. That is, suppose I'm taking sodium. What is the formula of what is the atomic number of sodium? That is Z equals to 11. So 1s2, 2s2, 2p6. Now 2p6 is completely filled. अब किस पे जाना पड़ेगा? 3s पे. We have the next possibility 3s. So 1s2, 2s2, 2p6, 3s1. Same as it is if I'm going to Z equals to 12, it would be 3s2 completely filled. Now the point is if I'm talking about our aluminum 13, so 3s तो already fill हो चुका है because the s orbital has the tendency to maintain 2 electrons only. So we would give to 3p. Okay, तो बच्चे यही simplest thing है कि हमें अपने हर एक atomic orbital को maximum fill करना है, and when it is maximum filled we will jump to our higher atomic orbital. Okay, and keep that in mind that s has only 2 electrons, p has only maximum 6 electrons, and d has only maximum 10 electrons. Okay, because it has total 5 different orientation of atomic orbitals. है ना? dxy, yz, zx, dx square minus y square, dz square. है ना जी? So this is the way, this is the representation. How can we maintain our electronic configuration? Okay. अब मुझे इस बारे में थोड़ी सी और एक्स्ट्रा बात आपको बतानी है. वो एक्स्ट्रा बात क्या है? Let's see that. The point here is that our neon is completely filled. That is 1s2, 2s2, 2p6. ये maximum fill हो चुका है. Now, if we are going to Z equals to 11, Z equals to 12, Z equals to 13, it seems little bit tedious for us. It seems a little bit extra work for us that we are going to keep it repeat again and again. Okay, so just it's like just as the pronoun. जैसे हम इंग्लिश में प्रोनाउन स्टडी करते हैं ना कि बार बार एक वर्ड को रिपीट करने की बजाय वी टुक द प्रोनाउन, वी टुक द सर्वनाउन. ओके, सेम एज इट इज मैं इस पूरे की पूरी टर्म को रिप्लेस कर रही हूँ बाय नियोन. और कैसे रिप्लेस कर रही हूँ मैं कर रही हूँ इसको लाइक दिस, नियोन 3s1. तो सोडियम हैज द इलेक्ट्रॉनिक कॉन्फ़िगरेशन neon 3s1. I have kept that in big square bracket. Okay, so this is the representation. How can we put our electron equals to Z? Okay, simple enough. Same as it is, we can jump to the higher level up to 18, 19, 20. Okay, that is calcium. Now, up to calcium, up to potassium and calcium, they has the Z equals to 19, 20. We have start from 11. They have the same tendency in which our 3s and then 3p is completely filled. Okay, that means 3p is completely filled. Now we are going to our atomic number with Z equals to 21, and the atomic number with Z equals to 21 has the d atomic orbital. Because our 3p 4s is completely filled, we have to jump to 3d atomic orbital. So let's begin. What's happening over there? Let's start with scandium. Okay, let's start with scandium. बच्चे आई होप यू गेटिंग द पॉइंट कि कितना सिंपल है और एक ही सिंपल रूल है कि वी हैव टू जस्ट रिमेंबर दिस area, just remember how can we fill up our atomic orbitals in increasing order, and then we have to keep the electrons according to the atomic orbit. Okay, which atomic orbital has maximum tendency, उसमें हम उतने electron fill कर देंगे. When it is completely filled, we would jump to the next step. Okay, same as it is ऐसे ही. This is nothing different, nothing hard. Okay, very simple to. So let's start with the topic scandium. Scandium Z equals to 21. Now 21, that means 1s2, 2s2, 2p6, 3s2, 3p6, है ना? 2 and 2 4, 6 10, 12 and 6 18. Argon has also 18, so we can just simplify it by argon. पूरे का पूरा जो आपका ये एरिया है up to Z equals to 18, we can put this up to argon. Now the point is there is 4s as well as 3d. See, we know that 4s has the lower tendency than 3d. So what would we do? We would do 3d 4s. First we have to fill up our electrons in 4s because 4s has the lower energy. So argon में हमारे कितने हो गए 18, 4s में 2, 3d में 1, or we can just to simplify it put as 4s 3d, 4s2 3d1. सही है? Argon 4s2 3d1 or 3d1 4s2, just to maintain it for beautiful, just to make it a little bit beautiful. Okay, so just to make it a little bit beautiful, we can also say 3d1 4s2. Okay, so this is scandium Z equals to 21. Same as it is, we can go to Z equals to 22, 23, 24 and so on up to 30. Now the point here is whenever we are going from Z equals to 21 to 30, there comes some exception, there comes a twist, and the twist is the extra stability of our half-filled and fully filled orbital. Let's see how. The topic right now I'm talking with is the most important topic. I have example of chromium and copper. Chromium and copper. Chromium has Z equals to 24 and copper has Z equals to 29. Now let's start. Up to 18, can I directly fill argon? Or if you want, you can say 1s2, 2s2, 2p6, 3s2, 3p6. Up to 18, we have to maintain it. Right now, we would jump to 3d and 4s. Now, whenever we are going to our 3d and 4s, what's happening? To maintain it's up to 24, we have to keep our electrons in 3d as well as 4s. So argon 4s 3d 4s2 18 और 2 20 and 3d has 4. So the answer should be argon 3d4 4s2, but this is not our exact configuration. This is a wrong representation because it just becomes argon 3d5 4s1. Now the question arises, why is it happening that we are taking 3d5 and 4s1? See, bache, it is the extra exception. It is the reason that our half-filled and fully filled orbitals, not only d orbital, either it is p orbital, either it is s orbital, they are extra stable. They has the maximum stability. So to maintain that one electron from the lower energy level, that is 4s, is jumping to the higher energy level just to maintain the extra stability. Keep that in your mind, that half-filled and fully filled orbitals are maximum stable. So ये जो representation है, उसने खुद ब खुद उसको इस way में arrange कर लिया. The electron in 4s has jumped to the higher level and has maintained 4s1 3d5. Done? Simple hai? So now can we move to our next topic, next exception, that is copper Z equals to 29. Z equals to 29. That means argon तक हमारा 18 हो गया. 3d है, 4s है. 4s हमारे 2 completely filled हो गया. 18 and 220. 3d 9. Same as it was 3d4 4s2 and it was wrong. Same as it is our argon 3d9 4s2 is wrong, and it would become argon 3d10 4s1. Argon 3d10 4s1, because D has the 5 and 10, D5 and D10, they has the extra stability. See how? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is our half filled. This is our half filled, means our atomic orbitals are half filled. Every has the एक single electron. Same as it is if I'm putting it completely filled, that is D10, it is also maximum state. Okay, so the next topic is what is the reason behind the half stability? Sorry, what's the reason behind the extra stability of half filled and fully filled atomic orbital? Okay, just a 2 to 3 minute topic, and this was all about the electronic configuration. Same as it is now, 3D is completely filled, 4S is completely filled. We will jump to 4P, then 5S, then 4D, and we will keep moving. We will keep going. Okay. So the point here is हमें ये एरिया याद रखना पड़ेगा. अगर याद रख सकते हो तो उसके लिए एक शॉर्ट ट्रिक है. अगर याद नहीं रखना चाहते हो तो we have to keep in mind the n plus L rule. Lower the value of n plus L, lower is the energy of atomic orbital. Okay, just keep that in your mind. Okay, this is just a kind of trick so that we can put this in this form. Okay, all right, so let's begin with our next topic. The question is stability of completely filled and half filled subshells. Why is it so that the completely filled and half filled subshells are more stable? The reason behind that is, should I rub this? Now the point is that not only D5, P3, P6, F7, F14, these all are half filled as well as fully filled orbital. And these are extra stable. This has been proven experimentally that these are extra stable, but the scientist has also given us 1 or 2 reasons to make us sure that yes, there is some reason behind this. That's why they are extra stable. They have told us that there is symmetrical distribution of electrons. What they have told us, that there is symmetrical distribution of electrons. What is symmetrical distribution? That means कि हर एक जो हमारा ऑर्बिटल है उसने एक इलेक्ट्रॉन को अपने अंदर फिल अप कर रखा है, उसके अंदर अपने आप को अटेन कर रखा है. So there is perfect arrangement. There is a great arrangement that everyone has a symmetry. Everyone has a order, a range. Okay. So the first point, according to the scientists, is that half filled or fully filled has the symmetrical distribution of electrons. That's why they are extra stable. Okay, second one, they have told us that suppose I'm taking D4 4s2, D4 4s2. Now the 4s we already know from the n plus L rule. हमने अभी study किया था that the 4s has something which is lower in energy, whereas 3D is something which is higher in energy. So the electron, to make that stability, jump from the lower level to the higher level, and we have D5 4s1 rather than 4s. Okay, so we know that our electron can jump from ground state to excited state due to some reason, due to getting some energy. So that's why, to just maintain that arrangement, that perfect arrangement, it jumps from the lower energy level to the higher energy level. Okay, so this was everything about the electronic configuration. If there is any kind of doubt or query, you can ask me, but just keep that